Hi, my name is Volkan Oktan, and I'm the Product Applications Manager here at Achronix Semiconductor. Today, we will be providing a demonstration of Snapshot, which is the real-time design debugging platform for Speedster22i HD FPGAs. As part of this demo, we will also showcase how the Achronix CAD environment, or ACE, demo GUI can provide direct real-time access to the FPGA. The demo GUI is completely independent of the Snapshot GUI, but both are embedded within ACE. Snapshot uses a JTAG interface to communicate with the FPGA core fabric. By instantiating Snapshot in your design, connecting it up appropriately, and compiling, you can take advantage of a wide array of features available in Snapshot, some of which we will review today. The Snapshot demonstration will be performed on the Speedster22i HD1000 validation board, with the HD1000 part clearly seen here in the socket. When we open up ACE and switch to the bit porter perspective, we can see the Snapshot debugger. On the Snapshot debugger screen, we see the pod name at the top. Over here, we have 3 sets of trigger channel information. This mechanism essentially determines the trigger condition by evaluating the pattern for the channel that is set to be cared. The monitor channels, with a configurable width of 36, 72, 108, and 144, are the signals that are being observed. The pre-store feature allows for customizable storage and output of signals prior to the trigger condition, to enable viewing of events leading up to the trigger. And here at the very bottom, we can provide the paths and names of the log and output waveform files that will be saved for the Snapshot session. In this demo design, we have a free-running 16-bit counter implemented in the fabric. Let's set up Snapshot to trigger when one of the dip switches, dip switch 0, is activated. This is done by setting the don't care mask and pattern accordingly. Let's also set pre-store to 25% to capture some of the events before the trigger condition is met. We then arm Snapshot and wait for the trigger event. As soon as we flip the dip switch, the trigger is set, and we capture a set of data which can be viewed on the right pane. By zooming in, we can clearly see dip switch 0 set to high at the trigger point. The pre-store value can be seen here, and the counter bits can be seen to be switching. We can reset the design and set a more complex trigger condition, this time triggering not only when the dip switch is activated, but also when the counter value hits, let's say, 15, 4 ones. Let's also assume that we are not interested in any data before this trigger and set pre-store to 0%. We can go through the same steps and see that once armed, when we activate the dip switch and the counter value hits 15, seen at the beginning of the trigger point here, the data is outputted on the screen. Clearly, Snapshot provides a powerful and flexible interface to debug designs by monitoring signals in the FPGA fabric. And we are excited about some of the enhancements we have planned for this tool in the upcoming months. The 3 main enhancements that are in the pipe are as follows. The first is to more than double the available widths of the monitor channels to enable more signals to be observed. The second is to provide monitoring depth customization to help with debug for more complex sequences of events. And the last one is to provide support for multiple instances of Snapshot within a single design. Each instance would be operating in its own clock domain with a master controller to provide simultaneous debug and observation capability for multiple signals in different clock domains. Let's also now switch to the hardware demo perspective to look at the Fabric Demo customized GUI. The demo perspective is completely independent from the snapshot perspective. The inbuilt demos that will ship with the HD1000 development kit will be accessible here. This console uses a USB interface that does two-way communication and refreshes once every 500 milliseconds. It allows for LED and dip switch states to be synced up, performs address register reads and writes, and will eventually display power and temperature information for the device. This concludes the Speedster22i HD1000 Fabric and Snapshot demo. Thank you.